All right, let's talk about dilations. This is the last of our transformation series. We've already talked about translations and reflections and rotations. Now we're going to talk about dilations. Before we get too far into this, there are some terms that you need to know. First, you need to know the term rigid motion. Rigid motion is any of our transformations that does not change size. That happen in translations, reflections, and rotations. We change the position, we still change the coordinates, but our figure, our object, did not change size. That's rigid motion. A dilation is very different than that. A dilation is a transformation that does change size. However, it doesn't have any of the other transformations in it. It's not going to reflect or rotate. It just changes size. So let's take a look at what a dilation does. Here I have my object. I've measured my coordinates. Now I'm going to take my object and I'm going to dilate. Now, please pay attention to the fact that there is something called a fixed ratio here. A ratio is simply a fraction. I'm going to change this fraction to a 2 over 1 fraction. 2 over 1 is the same as 2, of course, so I'm dilating with a ratio of 2. Now look at my new shape. You can see that it's much bigger. It's still exactly the same shape, just in a different size. Let's measure our coordinates and see what happened there. When I bring this up, to start, let's just compare A and A prime. What happened to my x values and what happened to my y values? They were both multiplied by 2 or doubled. Does the same thing hold true for B and B prime? Did I multiply my x and my y values by 2? And how about for C and for D? In each one, we multiplied our coordinates by 2. Remember the ratio that I put in the little dialog box was 2 over 1, which is the same as 2. That's called our scale factor. We enlarged this shape by a scale factor of 2. That means my new shape, all the coordinates and all the sides are twice as big as my previous shape. So I'm going to say that my new shape is twice as big or twice as large as my pre-image. All right, now we're going to try something different. I'm going to move these coordinates out of my way, and we're going to try a different type of dilation. All right. These might be off the screen, I just realized. So let's pull those over a bit. Now I'm going to, again, choose my new shape, or choose my original shape. I'm going to pull it out of the way just a little bit so that I can get the whole thing. Oh man. Let's try that again. And I'll just deselect the parts I don't want. Okay, now, do you know what I realized? I forgot to do something. I need to mark that as my center because I think I got off on that a little bit. Sorry about that. Let's try one more time. Okay, now we are going to dilate. This time, my fixed ratio, I'm going to put in a fraction of 1/2. You can see my fraction here of 1/2. Now when I choose dilate, notice my new shape. My new shape is smaller this time. I'm going to go ahead and measure my coordinates for my new shape. It does not want to cooperate. Let's measure our coordinates and move them up so that I can compare. I want you to see what's happening from pre-image to image. Let's start with A and A prime. I had 3 and 3, and now I'm at 1/2 or 1.5 and 1.5. 1.5 and 1.5. This time what happened to my coordinates? Remember our fixed ratio of 1/2 is 1.5 half of 3? That's right. So how about B and B prime? 2 goes to 1 and 7 goes to 3.5. We multiplied by 1/2 or took half of our number. C and C prime, again, we took half of our x and y values from our pre-image to get our image. And same thing happened for D and D prime. My image coordinates are exactly 1/2 of my pre-image coordinates. So I'm going to say that my new image is exactly half the size of my old image. Now when I say half, that means all of the sides are going to be half the length and all of my coordinates are going to be half of what they did or what they were before. So these are our dilations. I can either get larger or I can get smaller depending on what ratio I used. So let's continue. That ratio that I was putting in the text box is called scale factor. Scale factor is a hugely important term to know. The scale factor is the ratio I multiply my coordinates by to get my new dilation. There are two types of dilations. One is called an enlargement. An enlargement is a dilation with a scale factor greater than 1. So I could put in a 2 or a 3 or a 4 or even a fraction or decimal that's greater than 1, and that's going to make my shape larger. My image will be larger than my pre-image. The other type of dilation is called a reduction. Obviously that's going to make my shape smaller. It's going to reduce my shape. And that's any dilation with a scale factor less than 1. So that was like our dilation with a scale factor of 1/2. When I put in a 1/2, it made my image half the size of my pre-image. Enlargement, reduction, the only two types of dilations. Now just a side note in here, if I had a scale factor that was exactly 1, right? That would be exactly the same size. Nothing would change, okay? And that is not considered a dilation. If it doesn't change size, it's not a dilation. Now, you're probably wondering why I put k equals 1. That's because scale factor for dilations is represented by the letter K. So in my arrow notation for dilations, I'm going to take all of my points, x and y. I'm going to put an arrow to show that something's changing, of course. And since k is scale factor, I'm going to multiply my x values by k, and I'm going to multiply my y values by k. So this is the general rule for dilations. So if k was equal to 2, like in my very first dilation we did today, I would put xy now changes to 2x and 2y. Remember, that means I'm multiplying both values by 2. And in my second dilation, I used a scale factor of 1/2. So now I'm going to say that for all values xy, I'm going to change it to half of my x value and 1/2 of my y value. So arrow notation for dilations looks a lot different than the arrow notation that we have used before for other transformations. Make sure that you know the difference and that this is getting written down in your notes. All right. Make sure that you're writing down any questions you may have so that you can ask me in class the next day. Your assignment for this topic is the Dialations worksheet. You will need some graph paper to go with it. I have plenty in the room, so feel free to pick up a few pieces of graph paper to help you out with this assignment. Good luck!